For the last but not the least inhibition type being discussed in our class, we're going to talk about non-competitive inhibition, particularly pure. So we are given, well, quite intimidating number of steps, but this is quite simple than it looks. So here we have separate reversible steps for the enzyme substrate complex concentration, the enzyme inhibitor complex concentration, the EIS or the enzyme inhibitor substrate, and then the enzyme substrate inhibitor. So all these four are reversible, while the last one is the product equation, which is irreversible. And then we have about 9 rate constants, but we can actually simplify them according to ratio in terms of naming them. So for this pure non-competitive inhibition, to simplify this derivation, we are simply going to assume that equation 3 and equation 4 are 1. By the enzyme inhibitor concentration, these two will be 1. So therefore, k sub 4 over k sub 3 will be equal to k sub 6 over k sub 5. And then that would also be simplified since this is a pure non-competitive inhibition. So that means that this will result to increasing both the slope and the y-intercept while increasing the inhibitor concentration. So that will be further discussed when we reach the Lineweaver-Burke plot in class. And then, as usual, we assign our equation 1 with the velocity product velocity equation. And here in the naming, we have one new constant, which is the SI or the So this new constant here is the inhibitor attaching to the inhibitor site. So for the purpose of this derivation, let's just use SI to refer to this because we might be confused between 4 and 5. Okay, so let's proceed to the derivation of our expression. So we're going to express all of these in terms of ES concentration. So for the first one, this is simply transpose. The next same, we transpose. So for the third one, which is the EI, since we have an E here, we cannot plug this in because we have to express further in terms of ES. This is why we used the expression we derived for E and substitute it here, which will yield us this. So we observe that to simplify our life, we just rename it ahead since there are a lot of rate constants involved. Okay, so far so good. And just the usual, we assume that the total enzyme content is constant all throughout. Now this time we only have 4 since we assume that EI and EIS are 1. Okay, so we plug it in these, simply substitution, and then we take out the common terms. We have the reciprocal of substrate concentration. So here, this is supposed to be 1. If we only take out ES, this is supposed to be 1. But because we have a substrate concentration term here, we have to put substrate concentration so that once this will be multiplied with, we'll only have ES left. Then here, the constant, and then same as the other two. So the same thing for here. We observe that there is no S term here, right? So we'll have to fill in so that when we multiply the reciprocal, this will eliminate. So this is just a simple review of our basic maths. So next, we're still going to regroup them because we see that there are terms with this common variables, particularly substrate concentration and the constant substrate rate constant. And then next, we're going to get the ES term. So we're going to divide this whole thing to E sub O and then multiply the substrate concentration to the numerator. Then we're going to simplify further by taking out the common terms. Then we're going to plug this whole expression to our equation 1, and then we will arrive at this equation. Thanks.